Hey guys, this is Ref from Into Gaming. Today we're going to take a look at client-side prediction. More specifically, it's going to be client-side movement prediction that we're going to be taking a look at. And it's basically, it boils down to input responsiveness, but this has an effect on desync. It adds more of a delay to seeing what's really happening in the world of other players, but it also allows you to keep moving in your scene and having that, the hits behind cover and death behind cover and stuff like that, which can be frustrating. Um, the more you learn about how games work in this type of setup, um, the more it's not going to frustrate you when things like this happen. And you can actually start putting the blame on things where they lie. So with that, we're going to do a few simulations here. I'm going to run around with zero ping in two clients, and you can see how much delay is going on, and then we'll start upping the pings and seeing how far behind in time we're actually seeing the gameplay. So with that, let's jump right into it. So like I said before, we're starting off with zero ping. There's a server that boots up in the background that both my clients are connecting to here. I'll show you the little setup on that in just a few minutes when we jump into the other. So, all right, I'm the fellow in the black skin on the left. I'm running in third person perspective so you can see what's going on. So when I jump, I'm going to be using jump as our base movement to tell what's what. But when I jump, you can pretty much see on the right hand side that, yeah, he's fine. Um, Everything seems to be lined up. It's like microscopic. There's a microscopic delay here, and that's basically processing times at this low ping. And with no ping, your most all the delay is going to be processing times. And what I mean by processing times is with with all clients, we send the server at a set rate, just like the server sends us at a set rate. So, like if we look at Battlefield 6, it's got 60 hertz servers. So that means every 16 milliseconds, 16.667 to be clear, it's firing off an update to us. It has 60 updates a second, so we're getting data relatively fast from the server. Um, as far as its processing time. Clients have a processing time. My processing time is based on how many frames a second I'm getting. So if I'm getting 120 frames a second, my processing time is going to be 8.33 milliseconds, twice as fast as the server. If it's 30 hertz, if I'm doing 30 FPS, I got a 33.333 millisecond processing time. So with that being said, clients send the server updates about our actions and little RPCs, special little event calls, at a set interval. Not when you press the button. That stuff is all bundled up and it's sent off at a regular interval. So we might be sending, believe it is with Battlefield 6, we're doing 60 down and 60 up. We should always be at least 1-to-1 on the up rate. If they had 30 hertz servers, we'd probably still be sending 60 updates. So we'll be doing a 2-to-1 there. But for regular like Conquest and so forth, regular standard game modes, we're doing 60 and 60, I believe. I'm going to verify that. But we're sending at 16 every 16.667 milliseconds. So we inherit a little bit of delay there. So and then you got your ping time up to the server, 50% of your current ping. So if you have 100 ping, it takes 50 milliseconds for the server to get it. It sits in a buffer until the server starts the next tick. And then from that tick, it processes out. And as soon as it's done ticking and processing everything there, then it flushes out the results. And it's 50% of the other player's pings to get that data. So we're not all in sync with everything that's going on. Because I have a lower ping, I get data faster, I process it, and then it applies to my screen immediately. It's not waiting for everybody else with crappy pings to catch up. So on my screen, I could see somebody get behind cover before somebody else with a higher ping sees that person get behind cover. So we're all running our own simulation of the game based on how fast we get the data. And the bottlenecks for how fast, the big ones anyway, is ping. So let's look at network emulation. First off, I'm going to let you know that I am running a server in the background, just so it's very clear here. You can read in this statement, if the net mode requires a server, such as client, so if I'm playing in client mode, a server will be launched for me regardless of whether I tick this or not. Um, just so we're clear there. And we are playing as client. We can come back over here, look at down here, net mode, play as client. So that's very clear. We are having a server run in the background. And for this demo, the server is running at 30 hertz. I can't run it any higher than that. Everything gets kind of laggy here when you're running multiple simulations of things. So for emulation target, we're just going to apply pings to the players, to the clients. We're going to first start off with 15, a minimum and a maximum outgoing or incoming of 15 and 15 and 15. So it's not going to fluctuate. It's a steady, solid 15, no jitter, 1% packet loss. So that's what we're playing with right now. And you're going to clearly see that there's some offset here. You're going to start to see just with 15 ping, you're going to see some lag. I'm going to go into third, pull up a little bit, and there we go. You can already see player on the left gets the apex, the one that I'm controlling, gets the apex of the jump first and actually lands first. Apex land, apex land. It's just ahead. You can start to see it. So that's 15. We're going to jump that up to a 60 on 60 and play that. And you'll clearly see the nasty. And then we're going to do 100 ping, 100 versus 100, and you'll see how god awful that is. Alright. You can already see it based off the movement. Client side prediction and ping right here. You can see how much delay. So you can just imagine if I'm running and then I duck behind cover and I keep moving, but how long is it going to take my character on somebody else's screen to do it? How long is their shots going to take to get to me before I register them locally in my client? The stuff's got to get to the server and then to us. So if it's taking forever to get to the server because somebody else's crap ping, it's going to take forever to get to us. So there we go. Next thing we're going to do is 100 ping. Let me see. What's bad default? Yeah, it's close enough. I'm going to still keep it at 1. No, let me do 3. Let me show us a little bit of packet loss in there. So 100 pings with 3% packet loss. I'm going to do that, and I'm going to turn on show net corrections. So that basically it's going to show when the server corrects my movement. And my guy over here. Let's first take a look at those crappy pings. I'm going to change my skin real quick. Give me yeah, that works. Go into third, jump. And you can see that nasty delay right there. So that's 50 millisecond to the server. Server processes it out, shoots it out, and then another 50 millisecond to the other player, and then the whole game thread do the simulation, and then it queues it into a buffer for the render thread, and eventually the render thread gets it and then plays it. So that's what we're looking at here. So that's pretty nasty. So let me turn on net show corrections. Alright, and you can read that right there. Whether to draw client position corrections. Red is incorrect, green is correct. So when it shows a capsule component is what we're actually moving in game. Is the capsule. We don't move the mesh. The mesh just tags along with the movement component. So when when I move, let's see if I can get it to do it. Sometimes I have to get a little bit nastier, but there we go. See all those reds and greens and everything that is going on in there? So I'm getting corrected. I'm not noticing it, but the server is, telling me, hey, where you were in that particular situation was wrong. Um, so we can get this little burst of movement, and the faster I move, the typically the worse it gets. But and you can get it with packet loss, and I'll start doing all this crazy zigzagging around. So you're seeing the server actually um, tell me, hey, you were in this wrong position. And see, it warped me there for a second. Yeah, but you're seeing it there. There you go. There's a whole bunch right there for you to look at on the right hand side. You see it's just nasty. So there is correction happening, but I'm not really seeing it. It's not too jarring there. Let me see if I can punch this up. Um, let's just go with a bad and see what happens on that. It's only 2 clients, but imagine if there's a buttload more and you're having to process more on your end and whatnot. But you'll see that it's just spawning. I'm getting it. Just spawning. I'm getting this nastiness. Yeah, there we go. And the more back and forth jiggle movement that I do, all the crazy movement that you'll see players do, that little strafe craziness, that's when it starts getting really. If I stay on a regular path and I just change my base aim rotation, it's not too bad. But once I start jiggling around and going crazy, that's when things get wacky. Anyway, that's client side prediction, and we're showing the network corrections on that because the server is the authority. Um, And just to let you know, on the back end of that, the higher you get a ping, your higher your ping, the more network smoothing the server is going to apply. So you're not going to see other people warping out as much. But low pings can generally see other players warp out and do craziness. But um, that's network smoothing. That's a whole nother topic. But anyway, client side prediction in a nutshell, and its impacts on desync and how pings affect desync. I will be doing another video in a few minutes to post that right behind this one. It's just a whole thing on ping, and so you can wrap your head around ping, and I'll have some infographics so we can track input movements, um, or yeah, track our inputs on the server and how it processes, when it sends, and how clients read the data and so forth. So that'll be in another video that I post hopefully tonight. Anyway, thanks for watching. Have any questions? Post away.